Yeah. Hey, Rishit, I wanted to talk to your mom. Please ask her to ping me and we need to catch up.
Okay.
Okay, yeah.
Miss Priya,
Yes, ma.
I'm so sorry. This week's homework, I finished everything. Like I had everything uploaded, like 3 days ago. And then when I checked it today, because I had a few questions about the homework, so I went back to check the PDFs, and then I saw it wasn't submitted. So I'm gonna submit it right now.
Sure, no problem, ma, but I will go through. I was wondering, okay. But make sure you do your homework, guys. Check against answer keys. If you don't have ping, all that stuff, you need to take care of yourself.
Also, Miss Priya, where's
Mm.
the answer keys for this algebra?
Which module are you wanting? 1, 2, 3 has been given. So what module do you want now? What's the module number?
I don't remember what module it was. Can I check real quick?
Yeah, please. Check
Uh,
and tell me quickly. I'll help you with it.
Priya auntie,
Yes, ma.
I had a question on page 328 on problem 23.
We'll definitely do, ma. Give me 1 minute to get the answer key. Is that okay?
Yeah, that's fine.
Nice to see you guys working through it. Okay, so you want which module is it, ma? Do you know?
yeah, it's module 5.
Module 5.
Module 5 and module 6.
Module 5 and module 6. Okay. 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 Do you know how many are there? 5.1, 2, 3. How many are there? Do you know?
Um, when I was looking at the book, it just said 5, module 5 at the bottom.
Okay, no problem, ma. No problem at all. Okay. Hold on.
I can go get the book because
You
right
don't
now
need
I'm just
you
looking at
don't
the PDF.
you don't need to at the end of it. I need the input to go to you. That's all. Wait.
Okay.
Oh my God. File already attached. Okay. Module 6 I have. Hereafter. 1 second, guys. I will attach it right away. Wait. Module 7 I have. 7 I have. Let's see this one, guys. Give me a minute. So module 8 is there. So module 6, 7, 8 I'm done. Please ask whenever you don't have things. I have attached it in advance, ma. 9, 10, 11 I have. 5.1, 5.2. Okay. Okay. So 5, 7, 8, 9, 10, 11. I'll put it. Is that fine?
Yeah, thank you.
Yeah, I have posted that. 5, 6, 7, 8, 9, 10, 11 as well posted, ma.
Okay, thank
Okay.
you.
So you're not obstructed by me at all. Okay. Coming to, okay, let me go to Akshada's question next. But before that, I had something to do as well. Create material. Give me 1 second, guys. If there is anything missing in 5, you have to ask me, Subi.
Okay.
Okay, everything everybody should be able to access. I didn't want you to make you ask me for access. I feel in a way it's useless. But yeah, just have it for you to check. Don't abuse it. I'm relying on you not to abuse it.
Okay.
do all the problems. So we are meaning do everything that week itself. Otherwise, it will get bunched up for your CB exam. Okay, now we go. Here we go. Module 5, 6, 7, 8, 9, 10, 11. Okay. Okay, I'm here. No, there are 3 more people who are joined. Now, Akshada, page number what, Akshada? Page number what?
Page 328, problem 23.
28. Problem number
23.
23. Okay.
I had the same question.
Okay, sure. We went ahead with factoring polynomials I gave you, but I did not okay. So cubic you were able to do, is it? Okay, good. Am I making a mistake? Yeah, I am making a mistake. That's the deal. Hold on, see, that's what I am confused. So we covered cubic for you guys. 326 to 339. Okay, I see. Okay. Let's go over that. Hey, I wanted to ask Anisha, what are you doing in school?
We haven't done anything recently because the break came up and then we were just reviewing for the past week because we had a test.
That's okay, ma. What was the last one?
It was linear programming.
It was linear programming. Okay. Now then you're way behind, right? Good for me. Honestly, it's good for me. Okay. Let me quickly check something. Nisha, your mom's name. Okay. Okay, let me go back to my notes page. Okay, I'm going to share this with you all, guys. I'm going to share my screen. Okay. Okay. Before I get there, right, let's go ahead and do this one. If you're given, suppose for a cubic function, okay, I say that this is a cubic function. I would really like to have the equation, meaning you're going to write the cubic equation in the format 1 by b x minus h the whole cube plus k. This is the format in which I would like to have the equation. The points through which the function passes through are 1 comma minus 2, and then I have minus 2 comma minus 3, minus 2 comma minus 3, and then minus 5 comma minus 4. Can I have the function that passes through these 3 points? See whether you're able to do, otherwise I'll help you. Rishit, how about you? What are you doing in school? You're doing polynomials, right?
We're doing x to the power of 3 now. We're doing cubics.
Cubic. Okay, that's good.
Miss Priya,
Uh-huh.
is the vertex always the topmost point on a cubic function?
Not really, right, ma? Okay, in a parent cubic function, which is the vertex? Let's see. In a parent function, what is the vertex you're thinking? What are the reference points?
The origin?
Yeah, that's the vertex, right?
Okay.
So which is the h comma k? You tell me.
Negative 3 comma negative 3.
Negative 2 comma negative 3, you mean?
Oh, that's sorry, that looked like a negative
Yeah,
3 to
that's
me.
always taken as the h comma k. These three are reference points basically.
Okay.
Make sense?
Yeah, thank
See,
you.
similarly, in a it applies this for any function, the same things apply. Okay, here you have minus 1 comma 1, this one. 0 comma 0, 1 comma 1 is the reference point for a parabola. For a cubic function, is the same thing. You got it? 3 points that passes through the origin. This is the h comma k. So when this gets shifted, that becomes a transform function. Similarly, when this gets shifted, it becomes a transform function. Make sense?
Yeah, thank you.
Yeah. Once you know one thing, everything is easy. So that's what I keep saying. Initially, the transformation, if you solidify yourself, it's going to repeat and repeat. Anisha, But I asked you in this format, ma. Did you see that? Yours is right, no doubt. Okay. But then the format asked was different. I didn't ask for A. I asked for 1
It's
by.
not A. It's 1 over.
Yeah. No, but then when it comes inside, the value changes, right?
What do you mean? I can't write fractions in the. So I did 1 dash or 1/27.
No, 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 no. This
Oh yeah, I forgot to write the parentheses.
I didn't get you, lady. Honestly, sorry.
Like
What did you say?
g of x is equal to, and then I
Okay,
didn't
let
write
me
the.
write it down for you in your chat message itself. That way you'll understand, right? I just wanted it in this format, I said. Got it?
Oh yeah.
That's all. Because I asked you in the format B, right? I didn't expect A. Shreya, what are you doing in school, ma?
Right now, we just took our test, so we didn't really learn anything yet, like new.
Okay, taken, ma. That's fine. Learn anything new, know? What was the last topic that you can tell me?
We did the quadratic stuff.
You did the quadratic stuff. Okay, okay. Mm. The B value seems incorrect, ma. Subi.
Oh, I think I took it as -3 comma -3 instead of -2 comma
That's
-3.
okay, then leave it. Mm.
I'll just read it.
Mm. Give me a minute. I really want to see.
I'll send my answer.
Yes. I'll just check what is the curriculum once.
Miss Priya, I'll be right back. I have to grab something.
Yes, ma'am. Anisha, you had sent me your curriculum once, right, Anisha?
Yeah.
Did you erase that? Meaning, did your mom delete all of it?
No.
Would you
It's
mind
just
sending it to me once more? It's not there. Did you send it to me from your mom's or yourself?
my Amma sent it to me. Sent it to you.
Send it Amma, I don't know.
It's an image. Is she didn't send it as a text message. It was
Is
just
it
an image.
okay? Is it okay if you can send it once more? I don't see
Yeah.
it there. I don't know why, but can you send it to me once more?
Yeah. Can I do it after class?
Yeah, Amma. Do it after class is okay. Yeah, I just want to finish this anyway. So that's fine. Akshita, I'll check. 1/3. Cube root of why Rishit? Cube root of. Rishit, is this a cube root function?
Miss Priya.
Yeah.
This is not a cube root function, right, Rishit?
Oh,
It's a cubic function, right?
yeah.
Yes.
My bad.
Rishit, good job, Rishit. Good job, I think. So H is incorrect, Krishav. K, the sign is incorrect, Krishav. Akshada, your H and K are correct, ma, but your B seems incorrect. Subi, that is correct. So basically, guys, here, what you should have done, here you are just going to plug in, right? H comma K, you know, minus 2 comma 3. So I'm going to plug that in, right? G of x equal to 1 by B x, H is minus 2. So that becomes plus 2 in here. And then the whole cube plus K is minus 3. So it will be here like this. But we don't know the value for B. So you substitute any one x comma y, this or this. This is easier number, so I'm using that. So that becomes 1 and minus 2 here. So what happens? Minus 2 equal to 1 by B times 3, the whole cube minus 3. So what happens? Plus 3 on both sides. You get 1 will be equal to 1 by 3, 3, the whole cube. So I'm going to cube now. 1 is equal to 1 by B cube times 27. Multiply by B cube on both sides. What happens? B cube equal to 27, B equal to 3. Make sense, guys? So B equal to 3, I just plug it into my equation. G of x will be equal to 1 by 3 x plus 2, the whole cube plus minus 3. This is my cubic equation. Annam, Advait, did you follow?
Yeah.
Yeah.
Okay. Akshada, did you understand? Where did you get a Fatima?
I did minus K instead of plus K. I didn't, yeah.
You did
That's why I messed
plus
up.
3. I see. Shreya, did you understand how I got the cubic equation?
Yeah, I did.
Shrikar, how about you? I didn't get answers from you guys, right?
I sent mine. I sent it a little late, so maybe that's why. While you.
Okay. Krishiv, did you get it?
Yeah, you said I was correct.
You know, Krishiv, I did tell you afterwards that you got several things incorrectly. K's value was incorrect. K was a minus 3, right? H was a minus 2. It's not plus 3, I told you. Did you correct it, Krishiv?
Yeah.
Okay. Let me go ahead and give you one more. Let me quickly check. The cubic function passes through 0, comma 2.5 minus 1, comma 2 minus 2, comma 1.5. We are going to plot and understand which is h, comma k. It passes through. I'm just giving you 3 points. You are going to plot and find out which is h, comma k. So cubic function passes through the following points. Okay. Write cubic equation. Okay, what format? 8 times x minus h the whole square plus k equal to h of x. Write the cubic equation. With that, we'll go there. Okay,
You
we'll go.
want to write the cubic equation in the form of x minus h squared?
Yeah, sorry, ma. It was my mistake. Does that make sense?
Yeah.
Thanks for the catch, Anisha.
Also, is that not linear?
Is it linear? Why? Wait, let me check. Good question though. 0, comma 2.5. I have written correct. Minus 1, comma 2. Correct. Minus 2, comma 1.5. Why do you think it's linear? Because of, I know why you're asking whether it is linear though. It is cubic. You can, meaning, yeah, I understand where you're going, but it is cubic.
Okay.
I understand why you're asking this. Oh my God, I'm going to stop this. Go ahead. Oh my God, I got the answer. Press one. Good job, Shrikar. Shrikar, you got it.
I don't understand this. Can you help me?
Sure. Avni, correct. Akshada. Akshada, is it minus 1.5, ma? That seems incorrect. A value seems incorrect, ma. The whole cube plus 2. Everything seems correct, but the A value seems incorrect, ma. Akshada, what is that minus h of x?
Oh, I didn't mean to put that. That's the typo.
Okay, but then your A value seems incorrect. So, Rishit, if you plot it into a graph, right, it is 0, comma 2.5. 0, comma 2.5 can be here. 0, comma 2.5. And then what do you have? Minus 1, comma 2, right? Minus 1, comma 2.
Yeah.
You know that? Yeah. And then minus 2, comma 1.5. Minus 2, comma 1.5 minus 2 comma 1.5. If I draw a cubic line through this, right, I am going to draw like this. So this becomes my h comma k. H is minus 1. So if I want to plug in minus 1 and 2 into this, minus 1 and 2, I'm going to plug in into the k value, right? So if I plug that in, right, x plus 1 the whole cube plus 2 will be equal to h of x, but I still don't know the a value. So I take another 0, comma 2.5 and plug these in. A times 0 plus 1 the whole cube plus 2 equal to 2.5. I take that xy values to find out a. So a plus 2 equal to 2.5. A will be equal to 0.5. Rewriting this equation, the cubic equation becomes h of x equal to 0.5 times x minus x plus 1 the whole cube plus 2. That is my cubic equation. Does that sound good? Shreya, good job, Shreya. Akshada, correct, ma. Anam, yes. It's always the middle is the h comma k value. Does that sound good? Can I move on?
Yes.
Okay. Now, how about this? Okay. Okay. Let me go ahead and type this problem for you where okay. Used to maintain a breathable atmosphere for the columns. Okay. Estimate the radius of the biodome. Estimate the radius of the biodome. Okay. If it's required to contain 5.5 billion cubic Meters of air inside. How are we going to do this? Let's see, how are we going to do this? This is the question given. Makes sense. You're able to see the question, guys? Are you able to see the question? Okay, how do we get started with this? How do we get started with this, and why is it under cubic equation? Cubic functions. Hemispherical biodome. Hemispherical dome means it has to contain this much of air, this much volume of air in it. What is the volume of the hemisphere? What is the volume of the hemisphere? Thanks. What is the volume of the hemisphere, guys? Did you all forget? Guys, do you remember the volume of the sphere, volume of the hemisphere?
The volume of a sphere? No, not really,
Isn't
sorry.
it 2 by 3 pi r cube for the hemisphere?
Good, nice one. Yes. 2 by 3 pi r cube. Why? 4 by 3 pi r cube was for the sphere. 4 by 3 pi r cube was for the sphere. So it's half of that for the hemisphere. Half of it, right? Hemispherical dome means it's going to be like this, right? The colony is going to be a hemispherical dome, and inside the volume has to be whatever is mentioned here, 5.5 billion cubic meters. This is the cubic function. So volume in terms of R will be 2 by 3 pi r cube. What are they asking? Estimate the radius of the biodome. So the cubic function is already in here. Okay, there's nothing much we need to do. When you think about it, V of R will be equal to 2 by 3 times 3.14 times r cube. It's already a cubic function. They are just asking us to assess the radius. So you put this as 5.5 times 3 divided by 2 times 3.14 equal to r cube. Use your calculator to find out this value. That's all. Make sense, guys? Does it make sense? It's a cube root. Subi, what question you had on this, Subi? Did I clarify that or no?
Yeah, I kind of get it.
Mm-hmm. Akshada, did your question get clarified, ma?
Yes.
Good. Can I move on? If you really want to solve using graph, right? In a calculator, what you can do, literally y equal to 5.5, this side. Plot it as a line. On the other side, you can have y2 will be equal to 2 by 3, 3.14 x cube. Do this. Now, go to the calculator, plot this as one graph, plot this as the second graph. See what is the intersection of both the graphs. That intersection point will give you the x comma y. Meaning, it will give you the intersection point where the line intersects this cubic function, right? So that x value is the radius value here. That also makes sense. There are multiple ways of solving. Let me know if you did not understand. Krishav, did you get it?
Yeah.
Mm-hmm. What are the transformations undergone by this function? Who can tell me? Please volunteer, guys. If you don't know, please volunteer. If you don't know, please volunteer to answer. I'll help.
Up one.
Mm-hmm. Go ahead. Up one. Good. Let's do the translation at the last. This is up one, I understand. But let's do the translation at the last. So you have to begin with reflections and stretch and compress. Go ahead. Go ahead. Up one is correct. That's the last one. Go ahead.
There's no reflection, so
There's no reflection. Go ahead with stretches and compressions.
compression by 3.
Pluses and minuses are always translations. Okay.
By
Whatever.
by 3.
Go ahead. What was that?
Compression by 3.
Compression. Yeah, horizontal, right? Usually, if it is multiplication by 3, it is a stretcher. But for x value, whatever is inside the parenthesis is always on the horizontal axis. So basically, on the horizontal axis, this 3 indicates a compression. So horizontal compression by a factor of 1 by 3. Horizontal shift. So what is this minus 2? Do you remember, Krish?
Left 1. Left 2.
Left. Is it left or right?
Right.
Right 2. Because the x-axis, it's always the opposite. Right 2. And then up 1. Any questions? X-axis is always weird, Krishav. You have to remember that. Can I move on?
Yeah.
Okay. I would like to go to graphing polynomials. Yeah, that's an easy one. Let's see. Before I move on, right, I would really like coming to graphing polynomials. Okay. Let's consider our function f of x equal to x. It's a linear function, right? What is the domain? What is the range? What is the end behavior? That's what we are going to write for so many functions now. You can educate me, guys. I'll help. I'll help. Please volunteer, help out each other. I'm fine. We are going to do it for a lot of functions though. Go ahead. Can you help me from a linear function? What is the domain?
Negative infinity to infinity. All real numbers.
Negative infinity. We'll do interval notation, ma'am. Linear function is going to be like this. Okay, range is also going to be minus infinity. End behavior. End behavior, I'll be very, as x tends to minus infinity, y tends to minus infinity, this side, right? And then as x tends to infinity, y tends to infinity. See, x goes to infinity, y goes to infinity. Okay. Now, f of x equal to x square. How about that? How about that?
The domain is negative infinity to infinity.
Mm-hmm. Range. Please volunteer, guys. It's okay if you go wrong.
0 infinity.
As x goes to minus infinity, y goes to
Goes to
infinity.
infinity.
Positive.
As
And
y.
as x goes to infinity, y goes to infinity.
Yep. Y equal to x cube. F of x equal to x cube. What happens? The graph is going to be a chair, right? Go ahead.
The domain is negative infinity, infinity.
Range
Range
is.
is negative infinity, infinity.
But then as x goes to minus infinity, what happens? Y
Y
goes
goes to negative infinity.
yeah. Similarly, as x goes to positive infinity, y goes
Y
to.
goes to infinity.
If you didn't understand, this is the time for you to ask. F of x equal to x power of 4, you all know?
No, sorry.
This is going to be similar to x squared. Okay. But one thing what you need to understand is, before I go there, you know, hereafter, my end behavior is going to be like this. I'm going to mark it like this. See here, for the linear function, I'll mark it like this. Does that make sense? For parabolic function, I'm going to mark it like
To
this.
the power of 4.
Yeah, power of 4 will come, but end behavior, I'm going to mark it like this hereafter. Does that make sense?
Yeah.
Okay. Now I'm going back to x power of 4. What is the easiest way for me to understand x power of 4? I'll do a -1, -2, 0, 1, 2. X by table, literally. X power of 4 is 2 to the 4, 4 is 8, 8 is 16, 1, 0, 1, 16. So how will the graph be?
It'll look similar to x squared.
Yep, it'll look similar to x square. You can't, you won't understand the real x power of quartic. This function is called quartic. Okay, let me write out the name of the functions too, which I forgot to write down. So this is going to be linear, quadratic, cubic, quartic. Okay, now I'm going to come back to, it's going to be like this. But one thing what I need you to understand is, see, the power of x is 1 means only one time it touches the x-axis. The power of x is 2 here. So basically, when you see a transformed quadratic graph, many a time it will be like this. That means, see, it is go ahead and look at the transformed quadratic function. In a transformed quadratic function, when you look at it, it will touch the x-axis. Two distinct roots are there. Two distinct roots means two x-intercepts. Two x-intercepts means 2 times it touches the x-axis. Any questions here? Then you can ask, cubic means what then? It's touching only once. That's because it's not a transform function. That's why it's touching once. Otherwise, in a transform function, what would happen, you know? It'll be like this. 1, 2, 3. Usually, the highest power of x indicates the number of roots the function has. So power of 4, then what happens? You know, the transform graph will be like this. Makes sense? 1, 2, 3, 4. 4 times it will touch the x-axis. Any questions still here? Anya, you're following, ma?
Yeah.
Okay. This one is exactly similar to x square function, minus infinity to infinity, 0 to infinity. As x tends to minus infinity, what happens? Y goes to... Annam, are you following how I'm writing the end behavior?
Yeah.
Okay. Now, till what? Let's do till pintic. Or let's see. F of x will be equal to x bar of 5, quartic, pintic. How about this? So x power of 5 should be very similar to what?
X to the power of 3 or x to
3.
the power of...
Good. Yes, because the function is a odd function. So 1, 2. It is going to touch the transform function. First of all, I need to draw the parent function, right? Parent function is going to be like this. Very similar, okay? So I'll copy from this one, minus infinity to infinity, minus infinity to infinity. As x tends to minus infinity, y tends to minus infinity too. Any questions still here? Now, you know, I'm going to just change it. You know how I'm going to change it? I'm going to make a minor change. It's going to be minus x. So let me draw the end behavior for this as well. This one I forgot. This. And then the end behavior for this is this. Any questions? Now, let me see. I want to maintain the same thing, but I'm going to change my function. Okay, I'm going to change my function and I'm going to add a minus. So let me not add a minus there. It's so confusing. Okay, let's do this. Okay, now let me type my function. So just let me know how the end behavior is going to be. F of x equal to minus x. How the end behavior will change? For this, how will the end behavior? Will it change? It will change, right? It will invert. How it will invert? The arrow that was in here will go up like this because the function is going to be like this, right? Any questions, guys? What happens to that graph? How is the end behavior going to be? Guys, how's the
Down.
end behavior?
It'll face down.
Down. Both are going to face down.
Oh,
Yeah, both because the graph is going to be like this, right, ma?
yeah.
F of x equal to minus x cube. That's a little tricky. So how is it going to be?
Are you asking for the end behavior?
Yeah.
As x approaches negative infinity, y approaches positive infinity, and as x approaches infinity, y approaches negative infinity.
Nice. Okay. F of x equal to minus x power of 4 is just going to be this f of x. Do you understand the arrows? That's what I want you to understand. Nothing else. The arrows, did you understand? What is the meaning of those arrows? Hey, that's so important for graphing polynomials. Did you understand that?
Yes.
Great. Now, suppose, let's say, we will discuss how many roots and stuff. How many times the graph is going to cut the x-axis. All that stuff we are going to discuss, okay? I'm going to tell you a type of a function. First, let's find out the distinct factors. This will really help us ease in with, meaning when we go to graphing polynomials, it's going to be so easy if you understand this nicely. So let's see this one. F of x equal to x cube. How many distinct factors are there? How many times? How many distinct x values are there? Where y value is 0, meaning how many intercepts are there? That's the question.
0, 0.
Yep, all are 0. So distinct factors means there is only 1 and x equal to 0, correct? Okay. Now, f of x is equal to x. Let me have it this way. How many distinct factors are there in this function?
X to the right by 2. So
Correct.
x equals 2.
And how many distinct factors in the
1.
sense? 1. Why do you think it's 1?
No, wait. There's the y. There's going to be a different y and x-intercept. So 2.
What will be the x-intercepts?
2, comma 0.
And then? See, okay. What do you mean by x-intercepts or roots or distinct factors? You have to check for where your y value will become 0. When will your y value will become 0? When x will be equal to 0 or when x will be equal to 2? Am I making sense?
The 2.
X has to be 0. X has to be 2. When either of it happens, this function will become 0. So there are two distinct factors. What are the factors? 0 and 2. But 0 occurs 2 times. So that is x equal to 0 comma 2. Now I'll give you another function. F of x equal to x times x minus 1 times x minus 2. What happens to that? How many distinct factors are there?
3.
3. Good. So what happens? That means at x equal to 0, x equal to 1, x equal to 2, the function crosses the x-axis. X equal to 0, x equal to 1, x equal to 2. So the function is like this. Did you see this? The cubic function, right? Does that make sense, guys?
Yeah.
How do I differentiate this? I'll come to that later, okay? I'll come to that later, okay? Now, let me write out the x-intercept separately maybe. X equal to 0. This is x equal to 0, comma 2. Here as well, x equal to 0, comma 1, comma 2. Great. Okay, now, one thing what you should understand is here. Let's say the power, this x, the multiplicity, the number of times x equal to 0 occurs. See here. This is x equal to 0. This is x equal to 1. This is x equal to 2, right? The x-intercept I'm talking about. But the power here is called its multiplicity. Okay. If the multiplicity is 1, then the graph crosses the axis. It can be like this or it can be like this. Meaning, when the multiplicity is going to be 1, the graph, if it is below the x-axis, it will go above the x-axis, crossing that point. If the multiplicity is 1, at 1 what would happen? Suppose if the graph was here, right, from positive it might move to negative, or from negative it is just crossing across, it's just going across the x-axis if the multiplicity is 1. But what would happen if the multiplicity is 2? You know what? Here you see the multiplicity is 2. At that point 0, you know what happens? First, let's see. It's a cubic function. So end behavior is what is so important. How is the end behavior? Does that make sense? What are the x-intercepts? 0 and 2. Okay. We have the end behavior. It's on the positive side. It's coming here. It's landing on the 2. What happens on the 2? Multiplicity is 1. What does that mean? It crosses the axis. So it goes to the negative side. However, when x equal to 0, it again comes, the graph comes here. So I'll have to make a turn somewhere and go here. But at this point, x equal to 0, there's a multiplicity of 2. If it has an even multiplicity, right? When there is an even multiplicity on that x, right? It is a x-intercept. It has touched the x-intercept. However, if it is even multiplicity, it cannot cross, but it has to make a U-turn and come down. You got it? Does that make sense?
Is that for x to the power of like a
Yeah,
negative exponent?
when the power of the factor, when the power of that factor, let's say y equal to x square. Why do you think our parabola is like this? Yeah, the end behavior is this, you all know. So from here, you have an x-intercept here. So the graph comes and touches this. But then the multiplicity is 2. So it cannot cross and come down, but it has to go make a U-turn and go back. You got it?
Yeah.
This applies for any polynomial. See, this is a cubic polynomial. Suppose, let's say I have the function as x minus 2 the whole square. How will the graph be? First, let me draw the, always, if you want to graph polynomial, first end behavior, x-intercepts, multiplicity. Okay. So how is the end behavior? It's a cubic function, right? It's going to be like this. Make sense? Now, this is done. X-intercepts, where are they? 0 and a 2. Okay. Now what happens? This is done. I look at multiplicity. X, at x equal to 0, the multiplicity is 1. But I can't see. From here, the multiplicity is 1. So it crosses. It has to go up for sure. However, At 2, it has to come back to the x-axis again. I'm coming back. But the multiplicity is 2. So I'll have to make a U-turn, connect the end behavior. Make sense? For every point, if you're able to clearly understand what happens at that x-intercept, then graphing the polynomial is so much easy. Does that make sense, guys? Let's try for this one. Rishit, are you following?
Yeah.
Let's do a few more. Simple ones we'll do first. Let's say, see, if the number of factors grows more, there's some other way. But at least for the simple ones, let's see. F of x equal to minus x squared times x minus 2. Can we try this? What is the end behavior? What is the end behavior? Guys, you are going to tell me, guys, please. Otherwise, how will I know you all understood, right? It's not a questioning session, but then just to understand, just be interactive in the class.
Wait, what do you say? My
What is
internet?
the end behavior, Ma, for
It
this graph?
faces downward.
Face which side?
It's reflected on the X.
Yes. So, like this, intercepts are at 0 and at 2. Now, how do I do? I'll come from 1. Okay. From here, I'll go to here. I touch. What happened there? The multiplicity is 2. I cannot cross. I cannot come through. Okay. Because the multiplicity is an even number. So, I go back. Now, for again, we know that for reasons that there is an x-intercept at 2, it has to come back. It came back. But this is a multiplicity of 1. So it can cross and connect. Make sense, guys? Shreya, did you get it? Anya, did you get it?
Yeah.
Yeah.
Anisha, you're here. Did you understand?
Yeah.
Okay. Great. Okay. So now let's see. So here, let's find out the number of turning points. How many number of turning points we have? Turning point means U-turns. How many U-turns did we have in this graph? The first graph. This is just to make you feel comfortable with graphing polynomials. How many U-turns? Did we have any U-turns in this graph?
No.
No. Did we have any U-turns in this graph?
Yes.
Yes, because the multiplicity was 2, even multiplicity. Did we have any U-turns in this graph?
Yes.
Yes. Yes.
Yep. Okay. I'll make it as U-turn. I don't want turning points. Okay. So here it was it there here? But multiplicity is 1, 1, 1, right? Am I making sense, guys? U-turn means it's going to be like this, right?
Yeah.
It's going to be like this, right? Was there a U-turn here? It was always crossing, right, guys? Am I making sense or not? Here,
Not
was there any U-turn?
a tiny one.
Really? 0, 1, 2. Oh, see here, it comes like this. Oh, you see? So here, oh, you're taking this as a U-turn, huh? No. Okay, let me make it as number of U-turns at x-axis. Does it sound better? There's no U-turn at x-axis. At the x-intercepts, we don't have U-turns, right? Rishit, am I clear?
Yeah.
Okay, good. Number of U-turns at x-intercepts I'll put. Then what else? Okay. Do you all know what is global minimum and global maximum?
Yeah, wait, would that be like the lowest it possibly is, like negative infinity or infinity?
Yep, global max. Let's find out about global max. And if we have local max, we'll see. First, the graph for this will be like this. The graph for this will be...
Wait, Branty, isn't the global max and like minimum just the range?
No, global max is the highest point in the graph.
So isn't that like
Mm-hmm.
just the range then?
No. Okay, I'll show you.
Hey,
So
wouldn't
here,
that then be the relative max?
okay, ma. In a graph like this, right? Let's say you have a graph like this. When you look at it, these are relative maximum, relative minimum. Make sense?
Yeah.
Yeah.
Suppose, let's say I want a graph with a proper one. I don't want infinities. Suppose we have a graph like this. Like this. In this case, what is the global maximum? You tell me.
The first bump's tallest point.
This point is a global maximum, right?
Oh, I see. Okay.
This is the global max. What is the global? What is going on? What is the global minimum?
The first dip.
Hmm. What is the relative maximum?
Oh, now I get it. Wait, how
These
would
are
you do this? How would you do this with an infinite graph, though?
infinity cannot. Infinity cannot be global maximum or global minimum. You got
Okay,
it?
so this is only for finite graphs.
Mm. Does that make sense?
Yeah.
Okay. So now let's go ahead with this. Okay, global maximum minimum. I will again do next week, but I want to plot some graphs now. Okay, global maximum minimum, I'll do it next week. Now, at least till this you understood, right? Meaning, based on the number of factors, based on the number of x-intercepts, you will have that many crossing the x-axis. Now, based on your multiplicity, you will decide whether it is a U-turn at the intercept or crosses the intercept. Make sense? Okay. Global minimum maximum I'll have to cover next week, but I'll do that. In between, I really want you to understand how I do the graph. How I do the graph for a particular polynomial. Let me go ahead and do first time. Okay. Suppose I have a function like this. X times x plus 2 times x minus 3. What type of function is this? What type of function is this?
Cubic?
Cubic. So these are the x-intercepts. It's a cubic function. How am I going to graph this? As I said, first I'm going to find my end behavior. I already told you the step. Step 1 is going to be my end behavior. End behavior, first I'll mark it in the graph. Any questions still here? Second, I found out my x-intercepts and marked it in the graph. Any questions still here? Any questions still here? Can I go with the third step? Third step is a little difficult. Can I go with the third step?
Yeah.
I'm going to have a table. What is a table? I'm going to divide that into intervals. How? Minus infinity to minus 2. Minus infinity to minus 2 is my one interval. And then minus 2 to 0. And then 0 to 3. And then the last interval will be 3 to infinity. Any questions? The entire domain, I split it up into 4 intervals based on the x-intercepts. Make sense, guys?
Yeah.
Now, what is my function? My function is f of x equal to x times x plus 2 times x minus 3. Now, what will be the sign in this interval? In this interval, what is going to be the sign of my function? Can I use minus 3 to be substituted here? Minus 3 plus 2 is a negative value. Minus 3 is also a negative value. So my function is negative or positive? In this interval, between this interval, is my function positive or negative? Just plug in minus 3 into my function. Minus 3 x equal.
Negative.
Negative, because when you plug in minus 3, this is a negative number. This minus 3 plus 2 is going to be a negative number. Minus 3 is going to be a negative number. Negative times negative times negative is going to be negative. Make sense, guys? Am I making sense? Yeah.
Yes.
So this is going to be negative value. So throughout, see here, end behavior, I can connect here. In this interval minus infinity to minus 2, the graph is going to be negative value. So below the x-axis. Then minus 2 to 0, what can I do? Can I substitute minus 1 and see? Can I substitute minus 1 and see? X equal to minus 1 means what happens? What value do I get? What value do I get, guys? Yeah, I didn't get it. What value do I get? If I plug in some value within this interval, I'm going to wait. Am I not hearing? Positive or negative?
Negative. Wait. Yeah, negative.
Negative.
Why, Rishit?
A positive.
See, in your
Because
function, we are
yeah, it's
doing.
positive. My bad.
Yeah, no problem. See, we are learning here, right? It's going to be positive because if you substitute, see, any value, you take the easiest value, minus 1. If you substitute minus 1 plus 2, minus 1 minus 3. So what happens here? Minus 1 times minus 4. So it's going to be a positive value. So between this interval, the graph is going to lie above the x-axis and come back. Make sense? Then we go to our next interval, 0 to 3. I will take always, I'll take the easiest value. 0 to 3, what can I take? Maybe 1. 1 is the easiest. So is the value positive or negative?
Negative.
Negative. So it'll nicely stay below the x-axis and then come back. Then what happens? 3 to infinity. Can I substitute 4? 4 times 4 plus 2 times 4 minus 3. What happens?
Positive.
Positive. It wants to stay here, go join the end behavior. Make sense, guys? Did that make sense to graph? Are we all clear? This table really helps, right? So that's it. We did it. Can I give you one more? How about this? F of x, please draw and show me the video. Show me on the video and then we can leave. If you didn't understand as well, you will have to clearly say x plus 1, x plus 2. How will the graph be? The table is what is important when you have more intervals.
Miss Priya. Miss Priya.
Sorry, I'm muted. Go ahead, Masubi.
For the third one, does that say x plus
X
4?
plus 1, 1, 1, 1, 1, 1, 1, 1, 1.
Okay,
Sorry.
it's okay.
Wait, Miss Priya.
Uh-huh.
So do you want us to graph it or show you points, or do we?
Yeah. Oh, wow. Can I see the end? Anya, great, ma. But can I see? Show me. Can I see the end behavior on the left side alone? Left side alone, I want to see. What is the end behavior on the lemma? Right side, I'm seeing already. Left side, that is incorrect, amma.
Oh
What
yeah,
time?
I see.
You see it? Okay. They are not going to make you graph exactly on the points. No, but they want to know the shape of the graph. Correct, ma. Anya, you can leave.
Thank you. Bye.
Bye, ma. If you're stuck, I'm here to help.
Wait, so do you want us to graph?
1 second, guys. Tell me.
So do
Yeah,
you
I
want?
want you to graph. Yes. That's what is graphing polynomials all about. I'm going to leave for a minute and come back, and you can graph it and show me on the video. You got it? Got it? I'll wait.
I'm gonna put mine on camera now.
Thank you. Yes, Rishit. Good job. Thank you, Rishit. You got it, Rishit?
Yeah.
Good. Bye. Hey, safe travels to you all and have a happy break. Next week we are on a break. And when you come back, the password will change to Math Rangers. S added to it. Okay?
Okay.
Okay, guys.
Bye.
Thank you. Yes, Krishiv. Nice. Thanks, Krishiv.
Thank you. Bye.
Have a break.
Bye.
Please, yeah. Catch up on the homework. Akshada, there is a minus, right, ma? Did you forget? Because of the minus, what happens? Everything will get inverted, right, ma? That seems right. But Shrikar, I want to see. Yeah, Shrikar. Shrikar, there is no U-turn on the x-intercept. There is no U-turn on the x-intercept.
There isn't.
No. Can you show me once more? Maybe I'm looking at it incorrectly. Then I am sorry, but you can show me.
It's
See, yeah, but yeah, definitely that is not correct because I'll tell you why. When x equal to minus 1, what are you? That's better, Anisha. Correct, ma. You got it. Anisha, did you understand how to graph polynomials nicely?
Yeah.
Okay, good. Ma. Akshada, that's perfectly correct. You
Thank you.
understood the problem, Akshada?
Yeah.
Nice, ma. But did I clarify your doubt? You asked about the dome, right? Biodome.
Yeah, you clarified it.
Advait, Annam, I'm waiting for you guys. You can take your time.
I asked if you would show me.
Oh, yeah. I can show you. Yes. 1 minute, I'm checking. Yes, Avni, correct, ma. You can leave. Safe travels, happy break. Without math, you can be for a whole week.
Bye, Miss
Have
Priya.
fun. Bye bye. Subi. Yes, Subi. Correct, Subi.
Miss Priya, is it like this whenever it?
Yes, correct.
Okay.
That's correct. You got a difference?
Yeah.
Yeah.
I,
See, so at the x-intercept at x equal to 4, 1, minus 1, and 2, something has to happen for the graph to enter, meaning it has to touch the x-axis. Otherwise, your graph is incorrect. Does that
yeah.
make sense? I can show you if you want to. See, Here, when you think about it,
Bye,
in the
Miss
graph,
Priya. Thank you.
Parima, in the graph, see here x equal to 4, right? Right? And then x equal to 1, x equal to minus 1, and then it's also equal to minus 2. So these are the x-intercept. But before that, we forgot to mark the end behavior. What is the end behavior of this graph? There is a complete reflection of the x-axis. Usually x power of 4 end behavior is this, but because of this minus, it gets transformed to this. Now, let me go ahead and plot the intervals. What are the intervals? Minus infinity to minus 2, minus 2 to minus 2 to minus 1, and then minus 2 to minus 1, and then minus 1 to 1, right? And then 1 to, what is this interval? 1 to 4, and then 4 to infinity. Make sense? So minus infinity to minus 2, right? Till in this interval, where is the graph going to be? Is it negative or positive? Substitute some value, substitute minus 3. If you substitute minus 3, this is going to be a negative value. Initially, there is a negative sign, and then this is going to be a negative value, right? Minus 3, you're going to put, the entire thing is going to be negative, and this is going to be minus 3 plus 1 is negative, minus 3 plus 2 is negative. When you multiply 5 negatives, your f of x function is going to be negative. Make sense? And then minus 2 to minus, so it's in the negative side, below the x-axis. It cannot go through. It has to go through, I'm sorry, because the multiplicity is all 1, it has to go through. Now, between this minus 2 and minus 1 interval, right, you don't have a proper point, but then I will try to put minus 1, minus 2.5. Minus 2.5 is within this, right? Minus 2.5, if I put, this is negative, already one negative. Minus 2.5, this is also negative. Minus 2.5, this becomes negative. This is what? Minus, let's see, minus 2 to minus 1. Sorry, I should have put minus 1.5. This is minus 1, this is minus 2, minus 1.5 is between. So minus 1.5 means this is negative, minus 1.5 minus 1 is negative, minus 1.5 plus 1 is negative, minus 1.5 plus 2 is positive. So when you multiply 4 minuses, it will be on the positive side till here and touch here. Now it has to come through, because the multiplicity is 1 on all of these. See, multiplicity is 1 at x equal to minus 1. So it has to go through. Now, between minus 1 and 1, I prefer putting a 0. 0 is the easiest to put between minus 1 and 1, right? So what I'll do, I'll put a 0. If I put a 0, minus, then if I put a 0 in here, what happens? Negative, negative, plus, plus. It will stay in the negative side. Then you see, now what happens? 1 to 4. Can I put a value of 1 to 4? How to analyze that? 1 to 4, I can put a 2, right? So 2 minus 4 is negative. This minus comes here. This is negative. 2 minus 1 is a positive. 2 plus 1 is a positive. 2 plus 2 is positive. So what happens here? It is on the positive side. In this interval 1 to 4, the graph is on the positive side above the x-axis. Now, after that, what happens? 4 to infinity. Can I substitute a 5? 5 minus 4 is positive. 5 minus 1 is positive. 5 plus 1 is positive. 5 plus 2 is positive. So, all these, when you multiply, it becomes negative and joins the end behavior. Make sense?
Yeah, I get it.
Shreya, did you understand? Advait, Annam, did you
Yeah.
get it? Okay. I'll stop here and I'll assign homework on only graphing polynomials. Make sense, guys?
Okay.
Yeah, see you all after the break. Have a good week ahead.
Bye.
When you
Thank
come back,
you.
your password will be Math Rangers. Okay?
Okay.
Okay, guys. Bye.
Bye.
Okay, hi, guys. Give me a minute.